Welcome to the multivariable calculus section. In this section we'll be discussing triple integrals in spherical coordinates. So, multivariable calculus is designed to strengthen your ability to perceive and compute with regards to three-dimensional regions. So we've learned how to integrate using rectangular coordinates, polar coordinates, Cartesian coordinates, cylindrical coordinates, and now the last incorporation of integration would be in spherical coordinates. So, spherical coordinates are as follows. When we substitute for Cartesian coordinates, we say that x is equal to rho cosine theta sine phi. Y is equal to rho sine theta sine phi. And z is equal to rho cosine phi. So, each component has a rho component, and each component has a phi component. So, in prior, we had dv is equal to dz dy dx, but that's not the case. Additionally, r dz dr d theta is not going to fly with cylindrical coordinates. So in this case, we actually have the dv is set equal to rho squared sine phi dp, d rho, d phi, d theta, and that is going to be your dv. Additionally, we have the substitution rho squared equals x squared plus y squared plus z squared, and this comes up a lot when you're trying to find your function or your bounds for rho squared. So it's important to note that when we write this integral out, we're going to have bounds that look like the following. We're going to say that a is less than or equal to rho is less than or equal to b, and that means we're going to have normally integers or numeric values to represent p, so 1, 2, 3, 4, etc. Now we are going to have alpha is less than or equal to theta is less than or equal to beta. In representation for theta, as we know, we're going to usually expect something like 0, pi, pi over 2, pi over 4, etc. But a little note, most of the time this is actually going to be 2 pi and 0. Those are generally going to be our bounds. And for phi, we're going to say delta is less than or equal to phi is less than or equal to y, and again, this is going to be 0, pi over 2, pi over 4, etc., etc. So that is the ideology behind spherical coordinates. Essentially, all we're stating is that we want to say that beta alpha, and we're saying y delta, and BA of our function is given through with respect to rho squared sine phi d rho d phi d theta, and that is triple integrals in spherical coordinates. So I hope that helps. If you need additional assistance, there's a bunch on the website. Thank you.